that we've looked at the basic concepts for solving linear equations, or the basic properties for solving linear equations, we're going to go ahead and combine the previous two material into solving more complicated equations. So in order to do this, you want to know how to add, subtract, multiply, and divide integers. You want to understand how to simplify algebraic expressions using distribution and combining like terms. We want to understand how to solve basic equations using the addition and multiplication properties. Upon completing this presentation, you will be able to solve linear equations that involve two or more steps and check your solutions by plugging your result into the original equation. So our procedure, in order to be able to do these problems, the first thing that we want to do is clear parentheses using the distributive property. Note that just like with order of operations, we start with parentheses. Solving equations, that will always be our first step as well. Our second step, we want to simplify each side of the equation. By simplifying each expression, we want to combine like terms on each side. From there, we get to our click step. We want to move all variable terms to one side and all constants to the other side, using the addition property of equality. Now, one thing to note here is that it does not matter which side you move your variables to. Doesn't matter what side you move your constants to. The important thing is that they are on opposite sides of the equation. Once we have our variables on one side and our constants on the other, we want to use the multiplication property to isolate the variable, meaning divide both sides of the equation by the coefficient. In this section, we will not have any where we need to multiply by the reciprocal. We will not have any fractions. So we will go ahead and just divide. Our final step, we want to check our solution by substituting the number back into the original equation and simplifying both sides. If it checks, then we're good. If it does not, then we do need to go back and retry it and figure out where we went wrong. Note, you are only allowed to change the signs, do the opposite, if you are defecting to the other side. If the terms are staying on the same side and you are just reorganizing them, they do not change sides. You are only simplifying the expression. I point this out again just because this is one of the most common mistakes that students make. All right, so let's start with some basic examples. If we look at example A, if we follow our procedure, note that we do not have any parentheses, so we don't have to worry about that step. Also, we cannot simplify either side of this equation since we do not have like terms on either side, which means that we want to start by moving terms around. We want to start with our solving steps. So the first thing that I want to do is I want to get my x terms all on one side. We're good there. And I want to get all of my constants on the other. Since all of my variables are on the left, I want to move my constants to the right. So the first thing that I want to get rid of is the plus 3. In order to get rid of this, I want to subtract 3. The opposite of adding 3 is subtracting 3. So if we subtract 3 from both sides, my 3's cancel on the left, leaving me with just 4x. And 27 minus 3 is 24. That takes care of that step. The next thing we want to do is to get x by itself is to get rid of the 4. Since this is 4 times x, I want to get rid of multiplying by 4, and the opposite of multiplying by 4 is dividing by 4. So on the left side, my 4's cancel, leaving me with just x. And on the right, we have 24 divided by 4 is 6. Finally, our last step is we want to check our solution. Again, the reason is so that you don't have to wait until you get your test back or your quiz back to know whether you did it right or wrong. You can check this all on your own. So I want to go ahead and go back to my original equation and plug 6 into x. So we're going to replace x with 6. We get 4 times 6 plus 3 equals 27. We want to simplify both sides. 4 times 6 is 24, using order of operations, plus 3 equals 27. And I do recommend that you go ahead and, even though you may look at this and say, well, of course 24 plus 3 is 27, remember that we should go ahead and simplify this down on the left, simplify on the right, and yes, we do get a true statement. So our solution is x equals 6. Okay, so let's go ahead and look at the next example, example B. Example B, we have negative 4y minus 15 equals 25. So my first step is, again, we want to start with our solving steps. We don't have any parentheses, and I cannot combine like terms on either side. So the first thing I want to do is get all of my y terms on one side and all of my constants on the other. Since all of my y's are on the left side, we want to move our constants to the right. So the first thing I want to get rid of is the minus 15. In order to get rid of minus 15, I want to add 15. So if we add 15 to both sides, on the left, my 15's cancel. On the right, I get 40. So on the left, we have negative 4y equals 25 plus 15 is 40. My final step in order to solve this is to divide by the coefficient. Remember that when we divide, we don't change the sign. I want to divide by whatever the number is. So I'm going to divide both sides by negative 4. On the left side, my 4's cancel, my negative 4's cancel, leaving me with just y. And on the left side, or right side, we get 40 divided by negative 4 is negative 10. From here, we're done with our solving, so let's go ahead and check our solution. We get negative 4 times negative 10 minus 15, and I want to know, is that equal to 25? So following order of operations, we get negative 4 times negative 10 is positive 40. Remember that our signs, negative times a negative is a positive. So we get 40 minus 15. And I want to know, is that equal to 25? Well, 40 minus 15, yes, that is equal to 25. And so we do have a true statement, and therefore my solution is y equals negative 10. For my final problem, I'm going to do this two different ways just to show you that it doesn't matter how we do this. The first thing that I want to do is, we don't have parentheses, so we don't have to worry about that step. The first thing that I want to do is get all my variables on one side and all of my constants on the other. And I want to demonstrate that it does not matter which direction you go with this. So, me personally, I always like my variables on the left. In order to do that, I want to move the negative 2x to the left side. So to get rid of minus 2x, I want to add 2x. Now, me personally, I always like to move my variables first because I like to have control over that. If we do this, my 2x's on the right side cancel, and on the left I am left with 5x minus 14 equals 6. Since I moved all of my variables to the left, I need to move all of my constants to the right. So the thing that I need to get rid of now is I need to take care of the minus 14. To move minus 14, or to get rid of minus 14, I want to do the opposite, so I'm going to add 14 to both sides. If we do this, our 14's cancel on the left, leaving me with just 5x. And on the right, I have 6 plus 14 is equal to 20. Finally, I need to get rid of the 5. Since this is 5 times x, the opposite of multiplying by 5 is dividing by 5. If we divide both sides by 5, on the left my 5's cancel, leaving me with just x. And on the right, I get 20 divided by 5 is 4. And that's your answer. So now, let's redo the problem, just to show you that it does not matter. Starting from the beginning, instead of moving the 2x to the left, I'm going to start by moving the 3x to the right. So in order to get rid of positive 3x, I want to subtract 3x. If we do this on the left side, my 3x's cancel, leaving me with just negative 14. On the right side, I have negative 2x and negative 3x. We're combining them, so this is going to be negative 5x. Remember that we add and keep the sign. And we still have our plus 6. Now, since I have my variables on the right side, that means all of my constants need to go to the left side, which means that I need to get rid of the 6. I need to get it away from the x. So I'm going to subtract 6 from both sides. On the right side, my 6's cancel. On the left, I am left with negative 14 and negative 6. Again, I want to combine them. So I'm going to add the numbers, keep the sign. We get negative 20 equals negative 5x. From there, I want to get rid of the negative 5. I want to get x by itself. Negative 5 times x. In order to get rid of times negative 5, I want to divide by negative 5. And whatever I do to one side, I need to do to the other. On the right side, my negative 5's cancel, leaving me with just x. And negative 20 divided by negative 5 is positive 4. My negatives cancel, and so it is positive. So notice here that we do get the same answer both directions. So our final step is, let's go ahead and check that this is actually the correct answer. So if we plug 4 into our original equation, we get 3 times 4 minus 14 equals negative 2 times 4 plus 6. So 3 times, if we simplify both sides, I'm going to start by multiplying. 3 times 4 is 12 minus 14. Negative 2 times 4 is negative 8. I'm going to multiply and keep the sign. 12 minus 14, we're going to combine using addition and subtraction. 12 minus 14, since we have different signs, I'm going to subtract, keep the sign of the larger number. So we get negative 2 on the left, and on the right we're going to do the same thing. I want to subtract, keep the sign of the larger number, and so my answer does check out. So what does this mean? It means that my solution is in fact x equals 4. So why would we want to do this? Now, this problem wasn't a fantastic example, but for instance, some people always like having their variable on the left. Other people always like to move their variable term so it's always positive, but that wasn't the case on this one. So one of the things to keep in mind is if you check your work and it turns out that it's not coming out correctly, one of the things you can do is kind of move terms in the other direction to see if maybe that helps you solve your problem. Okay, so that takes care of some of our basic examples. And so now we want to go ahead and look at some more complex examples. These problems will involve our simplifying and possibly our distribution steps. So again, we're going to start with solving our equations, and let's go ahead and look at example D to start off with. Example D, we have 2x minus 8x plus 40 equals 13 minus 3x minus 3. The first thing I want to do is go ahead and combine my like terms on either side. So for the left side, I can combine 2x and negative 8x, and we get negative 6x. We want to subtract and keep the sign of the larger number since they are different signs. We get negative 6x plus 40. On the right side, I can combine 13 and negative 3. I'm going to again subtract, keep the sign of the larger number, so this will be 10 minus 3x. From here, we want to go ahead and do our solving steps. So I need to get all of my variables on one side, all of my constants on the other. Now, it's up to you. If you want to move them to the left, that's fine. If you want to move them to the right, that's fine. I'm going to go ahead and move them to the right on this problem just because I rarely get to do that. But for instance, you may decide that you want to add 6x to both sides, seeing that if we do this, we get a positive coefficient. If we add 6x to both sides, my 6x's cancel on the left side, leaving me with just 40. And on the right side, I am left with 10. Negative 3 plus 6 is going to be positive 3x. We have different signs, so we're going to subtract and keep the sign of the larger number. Since my variables are on the right side, I want to move my constants to the left. So I'm going to subtract 10 from both sides. On the right side, my 10's cancel. On the left, I get 40 minus 10 is 30 equals 3x. Finally, to get x by itself, I need to get rid of the 3. Since it's being multiplied to the x, we want to divide by 3. So dividing by 3, I get 30 divided by 3 is 10 equals. My 3's cancel on the right side, leaving me with just x. And so we have our solution. Let's go ahead and check the solution in our problem. and see what we come up with. So we get 2 times 10 minus 8 times 10 plus 40 equals 13 minus 3 times 10 minus 3. If we start with multiplication, we get 20 minus 80 plus 40 equals 13 minus 30 minus 3. So on the left side, the first thing that I'm going to do is combine my positives together. So if we combine our positives together, we have 20 and 40. This is going to give me 60 minus 80. I can do the same thing on the right side, or if you want, you can do 13 minus 3 to give you 10. Minus 30. And then now 60 minus 80 is negative 20. 10 minus 30 is also negative 20. That checks out. So what does that mean in terms of the problem? It means that 10 is our solution. And we're done. So let's go down to example E and see what we can do here. This is going to be problems where we start seeing parentheses. So as I mentioned, just like with order of operations, when solving equations, the first step is always to clear the parentheses. And so in order to clear the parentheses, we want to distribute. So for this problem, I'm going to distribute the 8 to both terms inside the parentheses. On the left side, I'm left with 5x. On the right side, I have 8x plus 24. Now, this problem is not a good example of moving your variable terms to the right. You'll have to do a lot more steps. Notice here that all of our constants are already on the right side. So the first thing I need to do is move all of my variables to the left. Remember that you have to have your variables and your constants on opposite sides of the equation. So I'm going to start by subtracting 8x from both sides. And if we subtract 8x from both sides, I get 5x minus 8x. I want to subtract, keep the sign of the larger number. We get negative 3x. On the right side, my 8x's cancel, leaving me with a positive 24. From there, we can go ahead and divide by the coefficient. We have negative 3 times x. To get rid of multiplying by negative 3, I want to divide by negative 3. So if we divide both sides by negative 3, on the left my negative 3's cancel, leaving me with just x. And on the right side, we get 24 divided by negative 3 is negative 8. If we check our solution now, I want to plug negative 8 into the original equation. So we get 5 times negative 8 equals 8 times negative 8 plus 3. I replace all of my x's with negative 8. Now I do want to point out that when we did our solving step, we used distribution. I will tell you I don't recommend using distribution when you are checking your solution, only because if you made a mistake distributing in the original problem, there's a very good chance you're going to do it again when you're checking. So when I'm checking my solution, I prefer following order of operations exactly the way we did when we worked with numbers. So the first thing I want to do is simplify inside the parentheses on the right side. If we do that, on the left we still have 5 times negative 8. On the right, I'm going to have 8 times negative 8 plus 3 is negative 5. And now if we go ahead and multiply, we get 5 times negative 8 is negative 40. And 8 times negative 5 is negative 40 as well. It checks, so we are good. And our solution is, in fact, x equals negative 8. All right, so we have one more example to look at here. Let's look at example F. Example F, this is going to involve all of the steps that we've talked about so far. So the first thing I need to do is I do need to distribute and clear my parentheses. If we distribute on the left side, we get 2x. 2 times negative 3 is negative 6 minus 17. On the right side, I want to distribute the negative 3. Make sure that you distribute the negative with the 3 as well. So we get 13 minus 3x. And negative 3 times negative 2 is negative 6. From here, we want to go ahead and combine like terms. On the left side, I can combine my negative 6 and negative 17. We get 2x minus 23. We have same signs, so we're going to add and keep the sign. On the right side, I can combine 13 and negative 6. So we get 7 minus 3x, or negative 3x plus 7. Either one would be considered acceptable. So now we are to our solving steps. I want to get all of my variables on one side, all of my constants on the other. For this problem, I'm going to move my variables to the left just because it involves adding 3x, which will give me a positive coefficient. On the right side, my 3x's cancel. On the left, I am left with 5x minus 23 equals 7. From here, we can go ahead and move our constants to the right side. I want to add 23 to both sides. We get 5x on the left, since my 23's cancel, and on the right we get 30. From here I can go ahead and divide by 5, and we get x equals 6. Okay, so last step, let's go ahead and check our solution. If we go ahead and plug this number into the original equation, we get 2 times 6 minus 3 minus 17 equals 13 minus 3 times 6 plus 2. Remember I said that one of the most common mistakes was people forgetting to distribute the negative, and so for instance, if you forgot to distribute the negative here, if you do it on your check step, you're likely to make the same mistake again. So this is one of the real reasons that I recommend simplifying inside instead of distributing. So let's see what we get. We want to simplify inside parentheses first. We get 2 times 6 minus 3 is 3, minus 17 equals 13 minus 3 times 6 plus 2 is 8. We can go ahead and multiply now. 2 times 3 is 6, minus 17 equals 13 minus 3 times 8 is 24. And now if we combine our numbers together, we want to subtract and keep the sign of the larger number. So 6 minus 17 is negative 11. 13 minus 24 is also negative 11. And so this checks out. Our final answer is in fact x equals 6. So there are some examples that are a little bit more complicated, and hopefully that makes sense. If not, please make sure that you ask in class, because this will be fundamental as we proceed to more difficult problems in the future. The last thing we want to look at in this presentation is some special cases. So let's go ahead and solve these equations like we normally would and see what makes them special. For the first example, we have 2x plus 6 equals 2 times x plus 4. If we go ahead and use our solving steps, the first thing we want to do is distribute. So I'm going to go ahead and distribute the 2 on the right side. The left side will stay the same. We get 2x plus 6. And on the right side, we get 2 times x is 2x. 2 times 4 is plus 8. From here, we want to get all of our variables on one side and all of our constants on the other. So I'm going to move my variables first. If we move our variables, I want to subtract 2x from both sides. And this is where you're probably going to go, wait a minute, it doesn't look right. Because on the left we have our x's canceled. There are no more x's. We are left with just 6. On the right side, our x's cancel there as well. We don't have any x's left there. And we are left with a statement of 6 equals 8. Well, this is a problem because 6 is never equal to 8. So this brings us to our first special case, which is if the simplified equation yields a false statement, then the equation has no solution. Note that we are not checking a statement, we are actually solving. And so if you get a false statement while solving, then your solution is no solution. There is not a single number out there that will make this work. So that's the first special case that we have. Let's look at example H. Example H, we have negative 3x plus 5 plus 5x equals 4x minus 2x plus 5. The first thing that I want to do on this one is I want to combine my like terms. So if we combine like terms, we get negative 3x, and 5x on the left side gives you 2x plus 5. And on the right side, we can combine 4x minus 2x and get 2x plus 5. If you want, you can stop there because I think that we can all see that we have the same thing on both sides of the equation. But if you want to continue solving, you can do that as well. My next step, if I was going to solve, would be to subtract 2x from both sides. And note that if we do this, just like on the previous one, our x's cancel on the left, they cancel on the right. The difference is, on this one, I am left with 5 equals 5, which is a true statement. Now keep in mind that we are not checking, we are solving. And so this is our last special case, or our second special case. And what this results in is, if the simplified equation yields a true statement, the equation is called an identity equation, and our solutions are all real numbers. The key thing to keep in mind here is all real numbers. There is an infinite number of solutions. Basically, what this means is you can pick any number that you want, and you will get a true statement. So, when it comes to linear equations, these are always going to be our 3 cases. You can solve and get one solution. You can try to solve and get no solution. And you can also have the case where any number would work, or an infinite number of solutions. In terms of linear equations, those are the only 3 possibilities. You will never have 2 solutions, or 3 solutions, or 10 solutions. It's always going to be 1, none, or an infinite number. So now, that brings us to the end of the presentation. So try the following problems on your own. Bring your solutions to class, as well as any questions that you may have.